about time to start. Yeah. Okay, so welcome to the talk today on JUnit 5. My name is Sam Brannen. I'm a principal software engineer at Pivotal since a few months, so to speak. I've been a Java developer for over 20 years, so quite a long time. And I've been a core committer for the Spring framework since 2007, where I originally rewrote the testing framework based on annotations with JUnit 4, TestNG, etc. And I maintain that still today. And I've been a core committer for JUnit 5 since October of 2015, so this combination is why I'm here talking to you today. So what we want to talk about today is what is JUnit 5 in general, what is JUnit Jupiter specifically. I'll give you a few tips on migrating from JUnit 4 if you choose to do that. Talk about some of the newer features since the original 5.0 release, a bit about the roadmap, what we have planned, and then a bit about using JUnit Jupiter with Spring and Spring Boot. So before we get going, I'd like to see a show of hands. How many people write tests? Hopefully everyone. Yes. Unit tests? Integration tests? More people? End-to-end tests? Fewer and fewer? Okay. In terms of frameworks, how about a framework called JUnit? Who uses that? Pretty much everyone. Anyone still on JUnit 3? No hands? All right, that's good. Who's on JUnit 4? Yeah. Latest and greatest, 4.12? Most, few people? Okay, right. So the last release of JUnit 4 is probably coming out in the next month or so, and that'll be JUnit 4.13. Is anyone already on JUnit 5? JUnit Jupiter? 3 or 4 people. Anyone use anything different like TestNG? One guy? Okay. Anyone use something like Spock? Yeah, anything else like Kotlin tests and stuff like that? 1 or 2 people? Okay. So fewer and fewer. So what is JUnit 5? Well, here we have the big picture. So we see at the bottom that we have this new platform. That's a new idea. That's what the IDEs and build tools will integrate with. You could use it on your own as well if you want to, but wouldn't be very likely. Instead, you're probably going to use what we call a test engine, and there are various different ones. We have one for what we call vintage instead of legacy, so that's supporting old style tests with JUnit 4 and JUnit 3. Then we have the new stuff, which is JUnit Jupiter, and you could be using some other third-party implementation, or you could write your own. So with JUnit 5, I kind of like to use a joke based on the matrix. There is no spoon. There is no JUnit 5. You can't just upgrade your Maven Palms and Gradles and say JUnit version is now 5. That doesn't work. So actually with JUnit 5, we rewrote everything, and we now have kind of 3 main categories of things. We have a platform, and we have Jupiter, and we have a vintage. So what is the platform? This is the foundation for launching testing frameworks on the JVM. Kind of a new idea. We have a launcher API in there, and we have test engine API that you can implement. And we have a console launcher, which is a way to run this from the console. We also have a standalone console launcher jar that you can download if you want. So Jupiter, that's actually the new programming model and extension model for JUnit 5. So when someone says, or when you read a blog, I'm writing a JUnit 5 test, this is probably what they mean, that they're using JUnit Jupiter running on the platform. And vintage, that's a test engine implementation that allows you to use JUnit 3 and JUnit 4 based tests, or other things like older versions of Spock that are based on JUnit 4 as well. So one thing I'd like to point out is that this first block here is actually revolutionary. That didn't exist before. People did write runners for JUnit 4, but they were kind of forced to go with the Java model. And the new platform is very generic in many ways. It supports files and directories and things like that, in addition to Java classes and methods. So the next part is evolutionary, right? That's where we wanted to do things better or differently than things were done in JUnit 4. And the last part's necessary because we want everyone to be able to keep running their JUnit 3 tests and JUnit 4 tests and Spock tests at the same time or simultaneously while running JUnit Jupiter tests. So in a nutshell, JUnit 5 is a complete rewrite of JUnit from the ground up, improving on what JUnit already had to offer, but with extensibility in mind. And it's modular, extensible, and modern, right? It's based on Java 8 and above. Another key thing that we had in mind, or kept in mind, was we wanted it to be both forward and backward compatible at the same time. So basically the platform supports JUnit 3, 8, and 4 with the vintage engine, and JUnit Jupiter with the Jupiter engine. Plus support for any other test engines that someone has written or that you may write on your own. And in fact, people have already written some test engines. If you'd like to check out and see what there is, just go to the wiki page for JUnit 5 and go to the third-party extensions page, and you'll see a list there, not only of test engines, but also of about 20 or 30 different extensions for JUnit Jupiter, so things like Spring and Mockito and other stuff like that. In terms of Java versions, this is a bit of poetry I posted a while back on the Twitter world. So works great on JDK8, so that's the baseline for JUnit 5. Works fine on JDK 9. We've always had automatic module names in the jars, and we're shifting in 5.5, adding more support for real module info if we can get that working. We also support module path scanning in addition to class path scanning. Everything worked again on JDK 10 and 11. EA is when I posted it, but now we're building against and testing against JDK 11 and 12, and we're trying with 13, but we have some issues. Not in our code, but in third parties and builds and stuff like that. So in terms of IDEs and build tool support, that's important to you because you actually want to be able to use this stuff. And good news, all the major IDEs and build tools support it. So IntelliJ since IDEA 2016.2, Eclipse since Oxygen 4.7.1, NetBeans more recently since Apache NetBeans 10.0. Gradle, so we originally wrote our own plugin. Gradle wrote it, added full first-class support in Gradle 4.6. Maven came on a bit later, Surefire 2.22, and they've improved it recently, allowing Spring Boot to adopt JUnit 5 in the past couple of days. So Ant actually beat the Maven team, surprisingly, and they have support since Ant 1.10.3. So I'm not going to show any examples of how to set this stuff up. If you want to see that, check out the user guide from JUnit 5 as well as some of the sample applications that we linked to. In terms of releases, so 5.0 was released back in September of 2017. Since then we've had 5.1, 2, 3, and 4 releases, the most recent being 5.4.2, so that's what you should be using. And we're working on 5.5 as we speak. So what is JUnit Jupiter? What is Jupiter? It's not a trick question. It's a planet, yes. Which planet? The 5th planet, yes. So JUnit 5, we didn't want to name it JUnit 5 because there might be a version 6 of it, and we thought it would be rather silly to have JUnit 5 version 6. So we came up with kind of a code name. And Jupiter starts with JU, like JUnit, and it's also the 5th. So we thought that's a good name, in case you're wondering where the name came from. So in a nutshell, JUnit Jupiter is, as I said before, the new program model and extension model in JUnit 5. The program model, that's how you write your tests, the annotations you use, the assertions you use, and assumptions, and the types of tests or the style of tests that you can write. The extension model, that's basically how you and third parties can extend the framework itself. So things like Spring and Mockito, Selenium, etc. So in JUnit 5 or JUnit Jupiter, we do have a more powerful programming model. Basically, you might ask yourself, what can you do with JUnit Jupiter that you couldn't do with JUnit 4? Quite a bit. Some things are simpler, like visibility. We don't require things to be public anymore. They just can't be private, but you can choose package protected and type less for your test classes and method names and stuff like that. We also support for custom display names. So instead of the limitation based on the technical names in Java, you can use the @DisplayName annotation and have spaces, special characters, and even emoji in your display names if you want. And since 5.4, we have a new DisplayNameGenerator with some built-in out-of-the-box support there, and you can also write your own. Tagging, you might know that idea from groups from TestNG or categories from JUnit 4. So in JUnit Jupiter, we have @tag, and that replaces the experimental @category support that was there in JUnit 4. In addition, we have a tag expression language, so you can say like this thing and this thing, or this thing and not this thing, and you can build up a tag expression to select which tests to run. So here's an example, calculator tests. Nothing too crazy here, but one thing you notice right off the bat is that there's no public keyword here for the class or for the method. And then in addition, we see this @DisplayName annotation. That's optional. You don't have to do it, but you can. So you can give meaningful full names, and you can use, as I mentioned before, emoji and stuff like that. Another thing to notice here is that we have assert equals, so the method looks about the same, but we have the message, the failure message in case it fails at the end. That comes now at the end instead of first. So if you're migrating, you would note that. Some tools will help you do it. Another thing to note here is that this is a lambda expression here. So basically, we lazily build up the exception messages if you're doing some kind of string concatenation or something that took a long time, right? Because you want your test suite to run as fast as possible. Here we see another example, again using some special characters in the display name, but something different here. This is also coming in JUnit 4.13, but we already had this since the start in JUnit Jupiter. So assert throws, this is how we do exception handling, testing for exceptions in the modern world, so to speak. So we say what we expect it to throw, and then we have a lambda expression or a method reference that's supposed to throw that kind of exception. And if it doesn't, then you get a failure, and otherwise you get a reference to the exception, and then you can check other things about it like the cause, the message, etc. Similarly for timeouts, We also have a similar way to do that with Lambda expressions. So we have two methods in the assertions class. We have assert timeout and timeout preemptively. So this first one, assert timeout, what that's going to do is going to basically wait on the code to complete. So if the code never completes, it could run forever. But if it doesn't, then basically we just check how long it took afterwards and fail a test if it took too long. And the other option is to say assert timeout preemptively. And in that case, what's going to happen is the code is going to run in a separate thread, and that means it'll be killed off if it takes too long. So you might prefer that. But with the latter, you have to keep in mind if you're using frameworks or any kind of tooling that's has something bound to the thread with like a thread local. For example, in Spring, you have transaction management is tied to the current thread for your tests. If you have @transaction on your tests, and that would mean that your the code running here would not run in the Spring managed transaction. So that's something you have to keep in mind with that. So basic demo just to show it all working. We should have that calculated test in place. We run it, shouldn't be all too exciting, but we would see, for example, in Eclipse that ran with, they call it JUnit 5, they mean it ran on the platform, and then it looks pretty much similar to what we've seen before. But we see we have some syntaxes here, right? So this must have been a custom display name, and you can double click on that and it goes straight to the method. So in the background it's tied technically to the methods and the classes, but the display name is just something human readable that you can use if you want. And here we have the example with the assert timeout preemptively and the throwing the exception here. So example, if we made this take longer, the guess is here if it takes, we say something like 45, it would take too long. If we run the test again, then we should hopefully see a failure. But with preemptively, it actually stopped after 1,000 milliseconds, right? So we don't know how long it would have took, but we see that it failed. So we have options like that. And again, the class doesn't have to be public, and the methods don't have to be public. One thing to note is that the test annotation is in a different package, so it might catch you off guard. Okay. So we have even more power and expensiveness. Meta annotation support. So meta annotation is an annotation on top of another annotation. It's kind of like inheritance for annotations in Java. And what it means when we say that we support that is that you can use any of the annotations in JUnit as meta annotations. So you can combine annotations, much like you may have already seen with Spring over the years. So you can create your own custom composed annotations. You can also combine them with Spring. So Spring supports it, JUnit supports it. That means you can use this feature together. We also have something called conditional test execution. So JUnit 4 just had add ignore, right? And you'll see we have more than that. Another thing we have is dependency injection for constructors and methods. So your test methods and also your lifecycle methods, like your before and after methods and stuff like that. Lambda expressions and method references can be used in various places, as we've just seen for some of the assertions, also for assumptions and dynamic tests. Another thing that comes along with Java 8 that a lot of people wouldn't naturally think about maybe on their own, we have this new thing, not so new, but in Java 8 we have default methods and interfaces. And when you have that, you basically can have multiple inheritance. And I like to call that testing traits. So you can have test classes that implement certain interfaces, and those interfaces can already have test methods defined or other configuration set up and teardown defined. So you can basically implement some testing traits and then override some abstract methods and have kind of a TCK or a testing kit, something like that. Another feature, there was some support for this with JUnit 4, some external runners, third parties. We have support for what are called nested test classes, so you can have test classes inside test classes, and it just adds a nice way, or introduces a nice way to group your test classes hierarchically, and also in terms of saving shared state and setup. We also have repeated tests, parameterized tests, and test factories for dynamic tests, so we'll take a look at those. Another thing a lot of people don't know about JUnit 4 is that JUnit has always instantiated your class anew, so new instance every time it ran a test method. And testing frameworks like TestNG did the opposite of that. They cached it. And so what we have in JUnit Jupiter is we give you an option. So by default it works the old way, using a new instance every time, but you can say test instance per class and then get one cached, and that has some benefits as well. Tagging and custom annotations. So for tagging, all you have to do is write @tag on an interface class or method and give it a string like this, @tag fast, and this is my fast test. But maybe you don't want to repeat that all over the place. Maybe you want to change the name at some point. So you can actually come up with custom tags. You can use the tag annotation from JUnit as a meta annotation on your own annotation. So here we're writing our own fast annotation. We've annotated that with @tag fast. Then we can just say @fast and @test throughout our code base, and we've kind of reuse that. But we can even go one step further. So I mentioned you can combine different annotations. We call those compose annotations. And here we see an example with two different annotations from JUnit Jupiter. We have the @tag annotation, and we have the @test annotation. And now we're saying @fast test, right? So we can use that across our code base. Another thing you might have is CI test or integration test or slow test or something like that. So different ways to categorize your tests and have a standard way to do it, and then a standard set of tags that you use for your build and locally. So next up, more advanced. Repeated tests. If you have something that's maybe a little flaky and you want to make sure something's idempotent and run a couple times in a row, you could say @repeated test and then give it a number. You can optionally accept a reference to the repetition info that allows you to find the total number of repetitions or the current repetition if that helps you, but that's not required. And then here you see another example. You can also override the name of the test. Here's a translation into German, but you get access to the current repetition and the total repetitions, and we'll see that actually running in the IDE. Next up, parameterized tests. So that existed already with JUnit 4. It's a bit different in JUnit Jupiter, and actually a lot more powerful in many ways. So basically, you annotate the method with @parameterized test instead of test, and you specify the source of the arguments, where they come from. You can optionally override the display name, similar to what we just saw with the repeated tests. So for the sources, there are multiple supported out of the box. @value source is the simplest. It allows you to specify your basic primitive types, strings or classes, and in the next upcoming version also Booleans as well. There's also support for null sources and empty sources for things like lists, strings and arrays and stuff like that. Enum source allows you to get access to the enum constants from a particular enum. Method source is basically a factory method where you write the code on your own to generate the list or the set of arguments you want to use. And then we have another thing called CSV source. So using the comma separated value list, that style, you can do it inline with CSV source in the code, or you can actually reference a file in your class path with the @CSV file source annotation. And if those things don't work out for you, you can write your own by implementing your own arguments provider and configuring that or declaring that with @arguments source. Now in terms of conversion and aggregation for the arguments, we have support for that. First up, we have implicit conversion for very common things, so like primitive types and their wrappers. So coming from a string, where it's a string and it's the 42, then it can get converted to an int or a long and stuff like that. We also have support for going from enum constant names into enum constants, things like files, URLs, currency, locale, things like that as well. Also time, things from Java time, so local date time, you might want to have that converted and used as a parameter for your method. And then more recently, we have support for factory constructors and static factory methods in particular classes as a fallback mechanism, and you can check out the documentation for that. Now, in terms of explicit conversion, if that stuff doesn't work, you can always provide your own conversion. You can do that by implementing your own arguments converter and then just configuring that with @convertWith. We also have support for patterns with the Java time conversion, so you can specify a particular pattern for the date format or the time format coming from your source, from your CSV file, for example. And more recently, we have support for what's known as argument aggregation. So basically, if you're reading in from a CSV file and maybe the line represents a particular order or a person, right, all the fields, you might want to have just the person object injected into your test method, and you can use aggregation for that. The way you would do that is you could use the arguments API or implement an argument aggregator, and that would then take all the input for a given set of values and then create one object. So that's somewhat similar to the row mapper from Spring JDBC support, if you know that. Here we have a concrete example. We have @parameterized test. When you have said we want this to be a parameterized test, and for the source, we're picking @value source. In this case, we're picking strings, so just a set of strings here. And this method will then be invoked 5 times, once for each of these strings, and the string just gets passed in as a candidate, and we can check, for example, our is palindrome method is working properly. Another option I mentioned is to have your own factory method. Instead of using the value source, you can say @method source. Originally, you had to specify the name, but in a more recent release, we also support the convention. If the test method name is the same as the factory method, you don't have to specify it. So this would actually invoke this method here, and whatever stream it returns here, those would then be the inputs for this method, and it would still be parameterized. Dynamic tests, that's something completely new, only really possible with Lambda expressions and method references in Java 8 and above. So basically what we have is a different annotation that says the method is not a test itself, but rather a test factory, so it generates tests. and it generates tests in the form of this dynamic test interface here. So instances of that, this dynamic test is imported here with a static import that will create one for you based on, you'll give it a name. This here would be test in, and it would be the actual test is the body here. This is this lambda expression or a method reference down here at the bottom. So in this example, just to show how it works, basically however you want to create some kind of stream. Here we're iterating, getting the first 10 even integers, and then we're mapping each of those onto one of these dynamic tests, and that returns as a stream of dynamic tests. And then each one of these will get invoked separately and reported as if they were standalone tests, and we'll see that in the IDE. Speaking of which, here we have repeated tests, as I mentioned before. We can just run that 5 times, and what we see is that we have another level here. So repeated test is now a container, and the things below that are the actual invocations for each of the repetitions. And with this other one here, we can see that you can have a custom display name. So here we see this German Wiederholung 1 von 5, so it's like repetition 1 to 5, just translated into German. For parameterized tests, we have these palindromes, as I mentioned before. This is the source, this is the stream of mom, dad, radar, etc. And if we run this, what we see is, right, so we see each invocation there coming up underneath, and we have the index displayed by default, but you could override that if you didn't want the index displayed. And each one of these, you can actually, should be able to rerun an individual one, which is a nice feature. Hopefully that works, because there's a filtering mechanism, so we see it actually only ran the one that I asked it to run in that stream there. In dynamic tests, similar, we have the first 10 integers and some strings here. If we run that, we see some similar results. So dynamic test is a class, strings is basically the factory, and then the actual invocations of the dynamic tests are listed as normal tests in the report. And if you were to double click on one of those, it would actually go to the factory, right, because there's no actual method there. But in theory, you should also be able to rerun test B, and we'll see if that works as well. Yes, so that's working as well. So the filtering, you have this support all built into hopefully all of the IDEs. So parallel test execution, in the past, you probably would have done that with your build tool or some other third-party library. We have built-in support since 5.3 in JUnit Jupiter for that. So basically you have to set it up. You set the JUnit Jupiter execution parallel enabled flag to true if you want to turn it on. It's not on by default because you may not want that. It might make your test suite not work so well, right, if you're not ready for it to run in parallel. You can also specify this in the JUnit platform properties file, or via the launcher API or your IDE or some of the build tools, or as a system property. So another thing you can do is you can configure the strategy to be used for how they should be executed in parallel. By default, it'll just be dynamic based on the number of CPUs and cores you have, but you can set a fixed number or custom strategy if you wanted to. Another thing to keep in mind, though, is synchronization. So you might want to pick or change execution mode. You can disable parallel execution on a per test basis, per class or a method, using the add execution annotation, for example, setting it to same thread, and that would say don't run it concurrently. But you could also turn on concurrency for a particular one explicitly. And controlling the synchronization, so sometimes things shouldn't run at the same time, right? You might think about like with databases and some kind of locks. So we have support for what are called resource locks, and it just takes a string. This is basically the name of the thing that's your resource. This could be my resource. There's some default things built in like system out, system error, locale, and stuff like that. So you can switch that up, and you can also change it from read-write mode to read mode. So this is all documented in the reference journal, but you have a good idea here what's supported. So let's just take a quick look at what that might look like. We have the parameterized tests. So right now, if I run it, it's calculating Fibonacci numbers. I have some log output, and we'll see how long it takes, approximately. It's running a bit long. It's still running, would appear so. So they all finished, 11 tests executed, down to Fibonacci of 44. And if we look in the console, we see it started out at about 08 and went down to 18. So that's about 10 seconds, right? Approximately. Now, if we wanted to turn on the support for having things run in parallel, we could just set this flag. I've done this in the JUnit platform properties file, enabled true. And if I rerun it, what's going to happen now? What do we see? We see it ran all 11. And now if we look at the time, just approximately, it started at 43 and went to 47, so that was more like 4 seconds, so quite a bit faster. Another thing we see here in this logging output is I've shown the threads that they're running on, so you see that the fork join pool is being used to run these things in parallel. We see multiple different workers executing at the same time. So that's one way to speed up your tests in your build and also within the IDE, and that's pretty straightforward since 5.3. So another thing about JUnit Jupiter is we really focus on extensibility. It's one of the things that's been the most important to me, coming from Spring, where we have also support for extensions for Spring's integration testing support, and now we have a similar, somewhat comparable model in JUnit Jupiter. So we have a new model, completely new. It's not like the rules you might have known from JUnit 4. Instead, we have what we call this extension API. Extension itself is an interface. It's just a marker interface. Doesn't actually do anything. But all the extensions that we have reside in this org JUnit Jupiter API extension package. And you can implement it as many as you like, which is nice. So you can pick and choose which extension APIs you implement in one concrete implementation. And you register that with @extend_with for registering one or more extensions at the same time. So you know, JUnit 4, you might know you couldn't have multiple runners. We support multiple extensions at the same time since the start for JUnit Jupiter. And you can register these things via an interface on the interface class or method level, or as a meta annotation. And then the last part, you might want to do this programmatically. So you can use @register extension on a field, and that's somewhat analogous to the @rule support and @class rule support you had from JUnit 4. So in terms of lifecycle callbacks, first up we have before all callback, and we have then an after all callback. So before all is like before class, and after all is like after class in JUnit 4. And then the next level we have before each callback and after each. And then we have something immediately before and immediately after the execution of your test methods. And those are the before and after test execution callbacks. So one thing to keep in mind is that these extensions, they wrap user-supplied lifecycle methods and test methods. So if we were to look, there's kind of invisible here, at before all methods, and these would be the after all methods, and then inside here would be the at before each methods, and at after each methods, and then inside here would be the actual at test method, or parameterized test and stuff like that. Next up, we have various other APIs we support as well. Execution condition, we'll talk about more of that in detail in a bit. Test instance factory, more recent. You can actually create the test instance on your own instead of letting JUnit instantiate it for you. Test instance post-processor, so you can set things in fields, stuff like that. Parameter resolver allows you to resolve arguments for constructors and methods. And these last three basically sum up support for dependency injection, and Spring actually makes use of the latter two, but not the first one. And this one is a mouthful, test template invocation context provider. Most people wouldn't implement it, but that's how we implement the support for things like the repeated tests and the parameterized tests. Those are more advanced. There's also support for handling exceptions. So if you wanted to write kind of your own expected exception extension, you could do that. Say you expect a certain kind of exception to be thrown. Test Watcher is brand new, so it's inspired by the one in JUnit 4. Basically allows you to see when tests have been disabled and skipped and stuff like that. Also new is DisplayNameGenerator. It allows you to programmatically decide what the display name should be, and the method order. So let's look at those last two in a bit more detail. And these are actually different from all the other extensions because these last two are applied during the discovery phase, so before the tests are actually executed. So when JUnit is looking for the tests. So this first one, DisplayNameGenerator, basically allows you to generate a custom display name for classes and methods. You can configure one via the display name generation annotation. You can implement your own if you want to, or you can use one of the built-in ones. Right now we have a standard one that's just the default behavior, and we have one that's called replace underscores, and not so surprisingly, it replaces underscores with spaces. So a lot of people like to write camel case-based test method names or with underscores in them, and this will just automatically replace them so you have these nice readable names in the report. So method order allows you to control the order in which the test methods are executed within an individual test class. Somewhat controversial, but let's not debate it here. In any case, sometimes there are needs. For unit tests, you probably should not be using this, but if you have something that's like some kind of integration test or functional test where the order matters with some kind of stateful thing or a database, then it might make sense to run them in a particular order. And the way you can do that is use @test method order. You can implement your own or use one of the built-in ones. We have alphanumeric, sorts the methods by their names and optionally by the parameters if they have the same name. There's the order annotation one, which allows you to specify at order and specify the number, so like 1, 2, 3, 4, and say run them in exactly this order. And then we have one for pseudo-random ordering, which can also be nice if you want to ensure that you have no dependencies between your test methods, which is normally a good idea. Then you could set up random for that. So this disabled annotation, I mentioned that earlier. What's the significance? This is this idea of conditional test execution. And basically, this is one place where the extension model meets the programming model. We have this execution condition API. You can implement that at disabled annotation. We have that, and it's actually implemented with a disabled condition. So it's not hard-coded or only special to JUnit Jupiter. Anyone can write one of these things. And this is basically a game changer, in fact, because anyone can write this. So again, JUnit 4, the only way you could have something disabled or ignored is by saying @ignore, and you couldn't have any kind of dynamic conditions. Well, another feature we have here is you can turn this off if you want to, maybe see if things that were disabled maybe should now run. Then you can basically specify a pattern specifying which conditions not to run for this particular test plan. Built-in conditions, so we have the disabled one since 5.0. In 5.1 we introduced a number more, so @enabled if and disabled if. Those might be deprecated soon, so maybe you don't want to look at that, but basically it was allowing you to use JavaScript to decide if a test should run or not. It's more popular things. You have the ability to say, run this test on a given JDK, like JDK 8, 9, 10, or not, on a given operating system like Mac or Linux, or if a given system property or environment variable is set or not. So that gives you a lot of power out of the box, and you can just throw in these annotations and then enable or disable your tests. So if you're on JUnit 4, a lot of people are asking the question, do I have to migrate to JUnit 5 or JUnit Jupiter, or do I want to? The answer is yes and no. Basically, you can run your JUnit 4 tests on the JUnit platform with the vintage test engine without changing them. They'll just work. So in that sense, no. But you can also run the JUnit 4 tests alongside the Jupiter test, again, in the same test report, which is also quite nice. So that's one of the benefits of this platform idea. And same project, same IDE, same build. You can also gradually migrate, if you want to, existing JUnit 4 tests to JUnit Jupiter, but you don't have to, right? You can just keep your old tests as they are, and then write new tests with JUnit Jupiter, and that's what a lot of projects do. But if you do want to migrate, some ideas or some things to keep in mind. Annotations. So test is still called test, but it's in a new package. @ignore is now @disabled, or one of those other disabled variants. Before class and after class are now before all and after all. Same for before and after, there's a before each and after each. Assertions have moved to a new class and a new package. The same holds for assumptions from JUnit 4. And the thing to keep in mind here is that this failure message comes last when you're migrating. So if you had a string, then you might have to make sure you get that right as the arguments. So we do have some support for migrating JUnit 4 rules. There's an @enable rule migration support. This is in a particular project that you have to include, JUnit Jupiter migration support. It's optional, experimental. It's probably not going to change, but it's more of an optional feature. But if you have that in there and you put this on your class, then it's going to automatically register 3 extensions from Jupiter, being these 3. So you get support for things like JUnit 4's temporary folder, error collector, and expected exception if you want to do that. Another thing we added more recently is support for the JUnit 4 @ignore annotation. So if you want to continue to use that, you can use this different annotation, @enable JUnit 4 migration support. It will register a condition for you that supports this @ignore annotation from JUnit 4, just like that disabled one from JUnit Jupiter. And it also includes the support that we saw on the previous slide. And another thing is if you're using JUnit or .JUnit assume, these assumptions from JUnit 4, and you're in the process of migrating, these will all work out of the box since JUnit Jupiter 5.4. So that means anything that throws a JUnit 4 assumption violated exception will be counted as an aborted test on JUnit Jupiter 5.4 and above, whereas previously it would have actually failed the test, and that was a bit confusing to some people. So what's new since the major release of JUnit 5? Some of the features we mentioned. One I didn't mention was we introduced the JUnit Maven BOM. So if you're not using Spring Boot, you might want to look into the BOM for simplifying dependency management. Parallel test execution, we saw that. There's also support for capturing system out and system error that came along with the parallel test execution. We mentioned that. Custom test sources for dynamic tests if you're into dynamic tests. If you're into Kotlin, the Kotlin support improves over time from external contributors that are really keen on using Kotlin. Register extension, test inspectory, and several more. More recently, some things to highlight. There's now a new JUnit Jupiter dependency that you can use. So basically it aggregates all of the main things from JUnit Jupiter, and you can just say you depend on JUnit Jupiter instead of the individual artifacts. So it just makes things easier. The XML report generating listener, we made that public recently. There's a new test kit, so if you're writing your own test engine, if you want to go that route, or if you want to test an extension you've written for JUnit Jupiter, then you can use the new test kit introduced in 5.4, and that makes it much easier to test those things. Timter support, so that was very popular, requested. There's support for that in JUnit 4 with the rule, and now we have support for that in JUnit Jupiter since 5.4. So you can basically have a Timter injected as a path or as a file, and you can work with that in your constructor or your test methods, etc. And then JUnit will clean it up for you afterwards. So basically just deleting the directory. That's all these. Ordering for tests. You can also order the extensions if you're registering them with @register extension via fields via the @order annotation. Okay, so what's up and coming? In JUnit 5.5, we already have some milestones out. We'll have support for Boolean values and value source. These built-in conditions, like running on a particular OS, on a particular JDK, stuff like that, you'll be able to use repeatable annotations for that, so have them declared multiple times. In terms of timeouts, I showed you how to do that programmatically with @assert timeout, and we're going to introduce support for declaring that you want a particular timeout for all of your test methods in a particular class and stuff like that. There's also a new invocation interceptor extension API that allows you to do things like executing the code in a user-defined thread, which might work nicely if you're using something like SWT. And if you're doing something more low-level, like writing your own test engine, there's a new configurable test discovery basic implementation that you can build off and extend from if you want. So in the backlog, there's other things we're looking at in the future. We want to add support at some point for using a custom class loader, for support for programmatic extension management instead of just declaring it with the annotations. We want to add support for first-class support for test suites, parameterized test classes. So I mentioned we have parameterized test methods right now, but we're looking at adding support for parameterizing a test class and having the same test class run multiple times with different input. Scenario test is something else we're looking at where you have multiple steps and they go in a particular sequence. And a new reporting format, so I've already shown some things like the custom display names and the dynamic tests, and we have different levels of hierarchies in the tests, and we need a new reporting format that supports these kind of things. So we're hoping to get that out in the next couple of months or so, but it'll probably take a while for the whole world to catch up, so we'll probably be using different formats for a while, or both at the same time. So that's it for the core about JUnit. I'm going to talk a bit about Spring and JUnit Jupiter, which makes sense since we're at Spring I/O. So who has actually used JUnit Jupiter with Spring? Anyone? Oh, okay. 6 or 7 people. I hope it went well. If not, come talk to me about it. All right. So it's been fully integrated in Spring Framework since 5.0 of Spring, and it supports all of the core integration testing features that you've come to know and love with Spring and Spring Boot. But in addition, it does some new things that weren't possible with JUnit 4 or TestNG. So we have support for constructor and method injection, dependency injection, using annotations from Spring like @autowired, qualifier, and value. And we also have support for conditional test execution with spell expressions. And we'll talk about that in a minute. Yep, we have some special annotations we can use to simplify things. It also works with Spring Framework 4.3 if you happen to be stuck on 4.3 and can't upgrade to 5.1 or the upcoming 5.2. And that's in my GitHub repository, and there's instructions there for how you can use it. So some people do use that if they want to go ahead and use JUnit Jupiter now with Spring Framework 4.3. But just keep in mind that it doesn't get new features. So the new features all go into 5.2, for example, for upcoming Spring 5.2. So to set it up, in JUnit 4 we had a Spring Runner. In JUnit Jupiter we have a Spring Extension. You can say extend with Spring Extension if you want to do it manually. But we have some nice composed annotations, so @Spring JUnit config, which combines the @context configuration annotation plus the registration of Spring. And similarly for web support, it combines the previous two with @WebApp configuration. So it just simplifies the configuration, makes you type less. And these @enabled if and disabled if annotations, they have the same names as the one from Jupiter, unfortunately, but these two from the Spring package work with spell expressions, so you can interact with beans from your application context and do things like that. So, brand new, since about a week. Some people have been asking for this. You might know that with Spring, historically you had to write @autowired on a constructor to have it picked, but since Spring 4.3, you no longer have to write @autowired on a constructor. If there's just the one, Spring will pick it and perform dependency injection for you. So basically what this does here is allows you to have the same feature in JUnit Jupiter when testing with Spring. So by default, as mentioned, you have to have it annotated, but this default can be changed. This is a global default now. You can do this by setting Spring test constructor autowire flag to true. It is by default false. You can do that via JVM system property or the Spring properties mechanism, which is a Spring.properties file in the root of the class path. Or you can override on a particular class level at test constructor autowire is true or autowire is false to change whatever the default is for this particular class. So Spring Boot, since Spring Boot 2.1, there's been pretty good support for it for JUnit Jupiter. Here I have an example of some custom config, so I wanted to write a Spring Boot test with @Spring Boot test, aptly named. I wanted to have the automatic MockMvc support, and I wanted to use JUnit Jupiter, so I could use these 3 annotations. Here I'm saying that I want to be able to declare it on my classes, and don't forget to save it at runtime, otherwise it's not in the bytecode, and the frameworks can't see it. And historically, you would have had to say extend with Spring extension. But since Spring Boot 2.1, Spring Boot test and the other slice annotations you might know, some of the other tests like the JSON tests, things like that, they're all meta annotated with this @extend with Spring extension, so you can just delete that since Spring Boot 2.1 and of course in the upcoming Spring Boot 2.2. So here I have Spring Boot tests, auto configure, and I've said @transactional. I have a sample application called Spring Events, and this is just for testing the web tier in that. So as an example, I wanted to show that with this method level dependency injection from Spring and this MockMvc that's getting auto configured for us from Spring Boot. So I can just say @Spring Events web tests on various controller tests in my project. This is just for my project. Optionally use a custom display name and here list events, and I'm saying @autowired MockMvc. So that gets injected and I can just use it locally. And this notion here of using @autowired on a particular method, it could be a good practice, but it could also be a worse practice. If you're doing it all over the place, then don't. Do it on the constructor if you want, or do it on a before each method, so you just set it up once. So you have to basically get a feel for that. But it's an option to do it at the test level as well. So one thing that people have run into rather frequently in recent months, people who are on various versions of Spring Boot who wanted to upgrade to the latest and greatest version of JUnit 5. There was a later version than the one that Spring Boot managed for them, and they couldn't figure out how to do it. So it's been a very popular question in various forums. For example, in this Stack Overflow question that I answered, and the answer is pretty simple. Read the documentation for Spring Boot. It tells you how to upgrade dependencies, but to spell it out for you, you have to find out what the name of the version is that Spring Boot considers as the name. And for JUnit 5, it's JUnit-Jupiter.version. For Gradle, you would set it like this. And for Maven, you would set it like that, so in your Maven POM. And then you can make sure you're using the latest and greatest. Now, the upcoming, or the recently released 2 days ago, Spring Boot 2.2 Milestone 3 already has the version set to that because that's the latest version of JUnit Jupiter. But it could be that JUnit Jupiter 5.5 comes out after the Spring Boot final GA release, so you might want to still know how to upgrade then or any point in the future. So as an example, we'll see if this works. I went to, what would Josh Long say? Start.spring.io, right? And I picked 2.2 M3, and then went with Gradle and selected the defaults. And what happened was I downloaded and unzipped it, imported it into my IDE, and that's this, demo. And if we look at the versions, what we see in there, we do see Spring Boot 2.0 and stuff like that, M3. And if we look at the JUnit versions, it's got JUnit 5.4.2 in there, and the Spring stuff, it has the latest and greatest Spring test 5.2.0 M2. So all of the new features I talked about there, you can use those. So what does it do? It creates a basic application. If you've ever used start.spring.io, you know it creates it with JUnit 4 by default, using Spring Runner, Spring Boot test. And what was this little trick I showed you? I said, aha, Spring Boot already annotated with extend with Spring extension. So you can use JUnit Jupiter or JUnit 4, whichever you pick. And the annotation here, that's org JUnit test. That's JUnit 4. And this will, of course, run. Shouldn't be a surprise. Ran pretty fast. But what if we wanted to get rid of the JUnit 4 stuff, right? Then for starters, we'd have to make sure we get the right annotation from JUnit Jupiter. And this thing's already registering the extension for us, so it should hopefully just run. Now it's running with JUnit 5. That worked fine. And just to prove it to you, right, you can take off the public if you want to, and it'll still run. And just as an example, some people like to have things private, final, and immutable if you wanted to. I don't have any beans in my application context. Environment, I spell it right? From Spring, environment. Why does Eclipse make that a capital E? No one knows. So now I have this private final immutable field that I want to be injected. Yeah. And I can make a constructor that's supported. Constructor from fields. Should all work. All right, that's there. And what happens if I run the test now? Any guesses? No parameter resolver. I couldn't find it. So what did I say before? The default, I said if you say add autowired from Spring, that should work, right? That was the one option. And then I said, well, what if you didn't want to do that? I said if you wanted to override locally, test constructor. Oops. That should also work. If we run the test again, that works. But what if we wanted to change it globally for our, so that could be like on a superclass or on an interface or something like that. What if we wanted to do it globally for the whole project? So now if I run again, it's going to fail. One option would be to take that. I hope I already have a run configuration set up here. I do. If we don't call it X, if we say Spring test constructor Autowire equals true, I'm setting this here for the VM for this current test, but you could set it for your whole build or via one of the properties files. If I run it now, we'll also see that it runs. So this is this kind of idea where you can have the private, final, and immutable fields in your test and use basic dependency injection just like you would in your normal components in Spring, like an @service, @controller, etc. So I'm glad the demo worked. You never know with these kind of things. All right, getting involved. If you want to help out, you can participate on GitHub for JUnit 5. Reporting issues, suggesting new features, participating in discussions, of course. You can also answer questions on Stack Overflow, or there's a Gitter channel that you can participate in as well. And if you want to, you can support the JUnit team with donations via SteadyHQ that helps with the further development for the contributors in their spare time. So in closing, I have some resources here for accessing JUnit. Basically, start at JUnit.org, get to JUnit 5. There's a bunch of links there you can see. There's a link to the reference guide, Javadoc, GitHub, stuff like that. Also, Gitter and Stack Overflow. There are links to those in the user guide as well. Demos used in this presentation are in my account, sbrannen on GitHub, JUnit 5 demo. I also used some examples straight from the user guide in JUnit 5. So one thing we do there is the examples in the user guide are actually executed in the build, so you're guaranteed that they work, the examples there, and you can copy them from the documentation project if you want. So we have a few minutes. If there are questions, I can answer them. If not, I have more demos I could go through, but I'll open up to questions first. No question? Yeah.
Is there any advantage? You know the way you said you don't have to declare public on the tests anymore.
Yep.
So does that give you any advantages apart from not?
It means
just
you can
not
type
typing?
less. Yeah.
That's it.
And and the other thing is some people don't like to see the tests as public types when they search for types in different packages and stuff like that. So that could be an advantage. But it's mainly about less is more. We don't make you type it anymore. Right. If you're using your IDE and it's generating for you and it makes them public, I wouldn't personally worry about it. But if I type in a new one, I just don't type the word public. That's it.
Okay.
Anyone else? Yes?
How it affects, like, if you migrate from version 4 to 5, how it affects the performance. Let's say our application takes 15 minutes in our test, between 15 minutes and half hour. So if you migrate to the 5 version, what you're thinking about it? Does it affect the performance? Like,
We've had, he's asking about the performance if you upgrade.
I'm just thinking about this parallel execution, so it's like.
Well, that would make it faster if your code works well for running in parallel, for sure. But in general, so there were a few bugs along the way where we had some things that we had to optimize. But as far as you know, currently, there shouldn't be really any performance difference. Yeah, it should run about the same. But with the parallel stuff, you can make it faster, and that's nice. So in the past, you could have done that with the build, maybe even like forking and running stuff parallel or Gradle. But Gradle does it differently, and with this does it within a class, like the methods within a class. So. Anyone else? Game over is what the sign says. So thanks for coming. If you have any questions, you can catch me outside.